Now the solvent as base, important concept. Without a solvent, you don't get a base nor an acidic solution. So one can look at if the solvent is relatively a base, in this case, so it means it's a proton acceptor, right? So when it's an acceptor, you can look at it as just a proton carrier, hydrated carrier. So let's use HL to represent, generally speaking, as a solvent. So as you put in a weak acid relative to the solvent, this is an acid, and this will be a base. So this is an acid and base reaction. And this would be the product. So this is a general formula, to the one we saw earlier with ammonia and with ammonium. So specific example, if you have weak acid, your solvent is H2O, then you get that, right? So when you have that, then you know the solution is acidic because this is responsible for being acidic solution, and this is your reaction product, okay? So this is your familiar water. Now what about the weak acid add into a different solvent? Well, H2O is the most familiar, but what about changing the methanol? Well, methanol, look at this as a carrier for proton, right? So once you understand that, you simply add a H plus to this formula, then end up with that, right? So this is essentially the same formula, then you just add one more H and become an H plus. Any question with that? So as a proton carrier, and A minus. Similarly, if relatively speaking, this weak acid, this is also weak acid, right? But then, because this Ka is higher than this Ka, let's say this is 10 to the minus 3, this is 10 to the minus 5, then this guy will behave as a base, relatively speaking. So now look at this as a solvent, a proton carrier, then similarly you end up with that, okay? Okay, for solvents, certain solvents, they have both the acidic as well as the base characters. So they have the two components. So what it means is, this kind of solvent can behave as a weak acid or behave as a weak base because they have the two components. So now the two components are relative to another chemical, so that one of the two character will expose because relative to another chemical. Now, if you write H2O into this fashion, then you can see it has this base component versus the acidic component. Now, H plus is acidic, okay, OH minus is basic alkaline, okay? So this kind of solvent is called amphiprotic solvent. Any question so far? Okay, then what about solvent as acid for amphiprotic solvents, right? They can add as base or as acid. So we just talked about water as a base, so it will accept a proton from a true acid. And now, what about acting as an acid? So this is solvent. So you put a base in, then reaction will be like this, so that the anion is exposed in solution. Okay, so if you have a base put into water, then you get this reaction product. Notice the OH minus will make the solution alkaline. Now, where the OH minus come from? When you put a base chemical, it doesn't show up as an OH. You may not know it is a base, right? But then the OH come from H2O, from H2O, right? So some of you may not know, okay, until now. So there could be an exam question. Then similarly, if you have a base put into that, then you end up with that, so on and so forth. The base into that, you end up with that. Okay, so the inherent acidity, when you look at a chemical, so the extent for ionization, how can you tell it is a strong acid or weak acid? Go back to it earlier, you need two substances. One is the chemical itself plus the solvent, okay? You must need to have two. So the extent depends on two factors. The first one is the inherent acidity to give the proton. So for example, then if you're looking at a chemical called HCl, then you know inherently it's going to be a strong acid. Versus layman, okay? Money versus proton, right? So this is useful and that is acidic. So Bill Gates, when you mention the name D. Bill Gates, then you know this guy is rich, potentially, has a lot of money. Not yet, you know, you just a title, you're a billionaire, you know, just the title, until you show off in here. Okay, you need a solvent. So now you have a polar solvent to accept the proton. Then you realize indeed HCl is such a strong acid. Without the solvent, HCl just sit there, HCl gas, okay? So Bill Gates in a shopping mall, right? Malls will allow you to spend unlimited amounts of money, right? So Bill Gates keep on spending, then see the money power. Then you realize Bill Gates is a rich guy, okay? So now, if you put HCl into a non-polar solvent, what happens? If they mix, it's not going to be acidic. Well, they are opposing each other anyway. They may not they may not mix, you know, just separate into two phases. So now this indicates, this shows an important concept, okay? So looking at a chemical formula, NaOH is a base because it has an OH minus associated with it, no problem, right? So once they go into water, then the mixture is going to be alkaline. Now look at NH3, ammonia. Why do you call it as a base? Well, it doesn't have OH minus in the formula until ammonia gas mixed in water, then you get ammonium and hydroxide. Bingo, when you get this species. Then refer to ammonia as a base because you add that in order to generate that. And this guy comes from water, not from ammonia. Okay? Any question on that? Okay, let's stop here.